So, of course, I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about advanced part modeling techniques in Onshape. And when we say advanced part modeling techniques, we're referring to anything we don't really get into in detail in our Essentials webinar. So, really intended for those that are getting started with Onshape, have maybe gone through the Essentials, created some basic features and parts, but are starting to dig in a little bit more, and getting into things like patterns and shell and loft and revolve and all the commands, again, that we don't get into detail in the Essentials webinar. So again, advanced part modeling techniques, really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address the questions from time to time. Now, there are always a few things that I like to mention about Onshape in general before I get into the topic of the day. And one of the first is our mission statement. That is getting everyone working together with CAD on any device, anywhere. So if you're new to Onshape, realize you can use Onshape on any device: Windows, Mac, Linux, Chromebooks, Android phones or tablets, iPhones, iPads. You really do have accessibility from any device. And it's true portability, meaning you can make a change to your design from your phone. Right? It's a full-blown CAD editing tool. You log in and you can make any edits that you'd like. But the other element of this is working together or working collaboratively. And if you haven't shared your document on Onshape yet, it's definitely one of the biggest benefits of Onshape, the fact that you can collaborate with others in real time on the same model. Whether you're in the same room or across the world, everything updates live for everyone. So those are just some things I like to mention about Onshape. Now, the other thing I always like to mention is, of course, we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's generally parts, assemblies, and drawings. And we do have all three pieces that make up a professional 3D CAD system. But there are a lot of things that are really unique about Onshape that I always like to mention, especially if you've come from a SolidWorks or Inventor or Creo or one of those types of typical installed CAD applications. The first is our frequent updates. With Onshape, roughly every 3 weeks, there's new functionality being added. The neatest thing about this is you don't have to do anything. You log in and new features will be there. There's no downloads or installs or update process that you have to go through. It also means that we move very quickly. So every 3 weeks, new features are being added, means we're adding a lot of features at a very fast rate. So frequent updates. Also with Onshape comes built-in version control. So in Onshape, you have the ability to create a version. And very similar to what you may be familiar with in terms of revision in many CAD systems, right? It's a milestone in the design. And the neat thing about this is a built-in function into Onshape that's something you normally have to manage and purchase separately. Typically, you would have to manage some kind of a PDM system and a file-based software. And Onshape, we have that ability built in. Also, with Onshape comes the ability to import and export common CAD formats. It somewhat ties into what we're talking about here today, but oftentimes you may have to work around other files or work with other files, whether that be your old legacy CAD data or just getting formats or files from different people. Working with other formats is critical. So we can import and export common CAD formats. I'm going to go over an example later where I'm going to show you how to work around or work with these imported models as well. So read and write common CAD formats. Also, entirely new methods of collaboration. I briefly mentioned this, but again, I encourage you to share your document. In the top right, there's a share icon. By default, everything you create in Onshape is private and only visible to you. But if you share with someone, you can collaborate with others in real time on the same model. So very neat stuff. And the neat thing is you always are aware of the latest state of the design. So entirely new methods of collaboration, real-time simultaneous editing across the world. Very neat stuff. Also with Onshape comes customization via FeatureScript. And FeatureScript is a programming language that we developed that allows you to build your own CAD feature. And you can build a CAD feature to save yourself time, ensure that it's always the correct size or dimensions, conform to standards, for example. And in general, it just allows you to tweak the CAD system in a way that no other CAD system will allow you. And it's really neat if you have a knack for programming and you're interested in building your own parametric CAD feature. So FeatureScript, customization with FeatureScript is really the last thing that I wanted to mention here before we get into the topic of the day. All right, so the topic of the day, sweep, revolve, loft, whole feature, shell, derived, patterns, and variables. So that's what I hope to accomplish in the next 55 minutes or so. So again, a lot of things to go through, and I wanted to start with sweep, revolve, and loft. I think those are important commands to cover. Again, things we don't cover in the essentials webinar, but then get into other important features: whole feature, shell, derived feature, patterns, variables, as many of these things as I can cover in the time that we have. All right, so enough slides. Let's jump right into Onshape. I'm going to start simple with revolve and sweep, and then I'm going to get into loft. I'm going to spend a bit of time in loft. Loft is a command that you can spend some time in getting it right, and then get into things like the whole feature, derived feature, patterns, even variables. So let's get into it. Now, the first thing I wanted to do, as I mentioned, is go through an example of a revolve and a sweep. And here I have a simple revolve part, something like a pulley, and then I have a sweep. Right? A simple example of a sweep would be something like this U-bolt. And what I'd like to do is walk you through examples of these two parts and some techniques or tips that I might give if you do a lot of these kinds of part design. So let's create new part studios. I'm going to create a new part studio, a new blank part, and we'll start with a revolve. So I'm going to start a sketch on the front plane. And one tip that I have, and this is just not what I would say a requirement, but definitely a best practice, is when you're sketching a revolve profile, especially the first sketch like I'm doing here, it's important to understand what is the rotation axis, right? And oftentimes I'll start with that. So if I'm picturing a revolve profile and I want to revolve it horizontally, I'll start with a horizontal construction line that references that axis. And doing this offers us an advantage later on when we dimension it as well. So just a tip for the revolve command. It's not a requirement, but it is a useful thing, especially when you have nothing like I have here, to start with your revolve axis. So I'm going to select line, construction, and then just draw a construction line horizontally through the origin. Now I can start constructing that revolve profile, the actual profile that I want to revolve. And again, I'm just going to go back to the line command, and we'll just start sketching lines. Now, think of sketching a revolve profile as taking a slice section of that round part and sketching just that. All right, so keep in mind, I don't need to sketch, a lot of users refer to as both halves, so to speak. You're taking that slice of the part or the sketch and rotating it to create a round part. Now, another tip that I have is, as you're sketching like this, one thing that you may run into is, I need to constrain the end of this line to the end point down here. But you'll notice it's not appearing as I drag that line back and forth. I need that reference to the point below. So what I can do is mouse over that point, then move my cursor up, and you can see now it will wake up that reference. Right? So just a tip, you can mouse over anything as you're sketching, and it will wake up the reference for that. So now I've sketched this profile, and I want to center it over the origin. Now this isn't specific to revolve profiles, but just in my case, I want a clean sketch. So I'm going to construct a line from the origin, right, vertically, like so. And what I want to do is I want to create symmetry about this line. Now, you could also mirror the sketch. So if you like that technique, you can use that too. In this case, I've already constructed everything. So I'm just going to create a symmetric constraint about this construction line. And that just makes sure that, click on more than one thing here, that I have the symmetry that I need. Right? So point, line, point, symmetric. And now if I change, you can see change dimensions on the length of these lines, for example, they remain centered about that construction line. So I just use symmetric constraint to align things, but now it's time to add the dimensions. And this is an important thing when we talk about revolve profiles. Remember, this is going to be a round part. And in my case, a full 360-degree revolve, creating a full round part. So when I go to add dimensions, adding a dimension like this isn't really helpful in most situations. I don't really want to define a round part by radius values throughout the entire thing, right? So a tip that I have is when you're adding dimensions, this should be an actual diameter value, right? Again, we're creating a revolve profile. If you move your cursor past that construction line, it will automatically double the value and add that diameter symbol indicating this is a diameter dimension. So just a tip, and it's another big reason why having that construction line horizontally through the center of your revolve makes sense. It helps for also dimensioning, like in this example, right? So now I can add a few dimensions and really define this in a way that makes sense, right? By diameter values rather than radius values. So I can add a few dimensions here. And we'll get to a fully defined sketch. All right. Now, you've finished your sketch, and you're ready to create the revolve. What's the next step in the process? Well, of course, you go to the revolve command. And you can go right to the revolve command from the toolbar. So I don't have to exit the sketch first. In the sketch, I can go straight to revolve, and it will automatically select, in my case, the sketch profile that I've determined. Now, it won't select automatically your revolve axis. So that's an important step in the revolve command. In this case, it's automatically selected sketch 1. You can see it in the top here, but I don't have anything in the revolve axis. So I can left click in the revolve axis dialog in that box, and then left click on my construction line. And remember, this is the first thing that we did in that sketch. It will then rotate again, driving this home, we're taking that sketch and rotating it to create a round part, and there is our revolve. Okay. One last thing to mention about the revolve command is that you don't have to do a full 360-degree revolve. You can say one direction, 45 degrees, right? Or, two directions, 45 degrees one way, 330 another way. So you can really specify a certain amount of rotation to your revolve rather than a full 360-degree revolve. And by the way, another popular one is symmetric, meaning, going in both directions evenly. All right, so that is the revolve command, a simple intro into the revolve command. The big tips that I would give you again is just the construction line to help define your revolve axis. It just makes dimensioning it and defining revolve axis very clean and easy. And also the ability to dimension to that construction line and then move past that construction line to give you true diameter dimensions in a scenario like that. So oftentimes in revolve parts, you want to define with diameters, and using a construction line will help you do so. So that is revolve. The next example I want to walk you through is sweep. And sweep's pretty straightforward. Like the name implies, you take a profile and sweep it along a path. And a good example of this is a U-bolt. A U-bolt, if we go back just a step here, is essentially just a circle swept along a U-shaped path, right? So in 99% of your sweep commands, you're going to define two sketches. I shouldn't say 99, but many times in a sweep, you're going to have two sketches, a profile and a path. And you can see in this U-bolt example, I have sketch 1, which is the U-shaped path, and I have sketch 2, which is just a simple circle that's attached to that U-shaped path. All right. So again, two pieces to a sweep. You can define a sweep's path using edges of your model. And that's what I say, there may be some occasions where you don't need to sketch a path, but for the most part, you will have two separate sketches. All right, so let's go about creating one of these. I'm going to create a new part studio. And I'm going to start a sketch on the front plane. Now, in most situations, you want to start with the path for your sweep, and that's because you need to attach the profile to it in order for a sweep to work. So I'm going to start with that U-shaped path for the U-bolt, and I'm going to start with a simple line at the origin, and there's our first line. We'll do a tangent arc off of that, like so, and then I'll finish with another line. Now I want to make sure I have my tangent constraint, so I can select the two, use the T key on the keyboard for tangent, and then just add a few dimensions here. Right? So we add a few dimensions to define our U-shaped sketch, but that's really all we need to do. right? So the first sketch is done. I can hit the green check OK, and now I have sketch 1 listed in my feature list. Now, a commonly asked question, this is just a random tip now that I'm thinking about it. How do I hide the planes? You can see I have all these planes in the graphics. A tip is use the P key to hide all the planes at once, or show all the planes at once. The P key will hide show. All right, so that's step 1. Remember I said that a sweep involves 2 important pieces. A path, which we've done. That's the U-shaped sketch. Now we need a profile for that. So I'm going to start another sketch. Now, an important tip is oftentimes I would say oftentimes, but many times you'll need to insert a plane. So in this example, it just so happens that the top plane is right at the end of our path. But you may not be so fortunate, especially if your sweep is, many levels down in your feature list. You may not have the fortune of having a plane exactly at the end of your path. So another tip that I have for you is inserting a plane. The reason this is so important is because you won't be able to, attach your profile to your path or create the necessary constraints if you don't have that plane. So let me give you an example of this, just because I think in many situations out there, this is a necessary step. It just so happens because my sketch ends at the origin, I don't need to do that. But let's say that I did. How would I insert a plane that's normal to the end of the path? And that's the common step in a sweep command. So what you would do is click the plane command in the toolbar, choose the curve point plane, and then choose a part of the curve, which is in this case the path, right? I'll select this line, and the end point of your path, which is just this end point. And what will happen is it will insert a plane normal to the end of your path. And that's an important step, again, if you don't happen to have a plane right at the end, right? So again, just keep in mind, inserting a plane, I would recommend using the curve point. Click on the path and the end point of the path, and you'll get a plane normal to the end of it. And then you can sketch your profile on that plane. All right, so as I mentioned, though, I just so happen to end this sketch right on the origin, which means I have the top plane that I can use. So we'll use the top plane and start a sketch. Now, in this example, you'll remember there's 2 pieces, the U-shaped sketch and the circle sketch. That's my profile. So I'm just going to sketch a circle out in space and then add a dimension to the diameter. Let's say 0.25. Now what I need to do, and this is an important part of the sweep process, is attach my profile, which is the circle, to the path. And oftentimes you want it attached to the end of the path. That's why inserting that plane at the end of the path is so important. So in my example, I want to attach the center of this circle to the end of this line. Now, I can do that just by left-clicking each point and giving them a coincident constraint, right? That will attach the center of my circle to the end point of my path. But again, it's important to stress with any sweep that your profile must be attached to your path in some way, either with a coincident constraint or a pierce constraint, right? Now, a question that's come up, I see a few questions. I have some problems with remove material and axial direction of the revolve process. Forgive me, I'm not following that. Do profile and path have to intersect? They do have to be attached to one another. So I hope I answered that with this example. You must attach your profile to your path in some way, either with a coincident constraint or a pierce constraint. Right? In this example, both would accomplish the same thing, but in more complex examples, you may need a pierce, or if you don't have a point that's right on the end, you may need to create a pierce. Okay. Is pierce particularly special compared with coincident? Well, remember that coincident may not always be there. For instance, if I wanted to attach this circle to a spline that goes, through several different planes, then I wouldn't have coincident as an option. Pierce would be my only option. Right? So in certain situations, pierce will be necessary, but think of pierce as where that curve that you're selecting pierces the current sketch plane. That's what a pierce constraint is. So there is no 3D sketch feature. The answer to that is yes. There is no 3D sketch feature currently. Okay, we do have a way with FeatureScript to generate a 3D spline, but we don't have a true sketch, 3D sketch feature as of today. Can a profile be attached with a construction line to the path? Sure. Yeah. It's possible to eliminate constraints on a given object. You can eliminate any constraints you want by checking Show Constraints and just clicking the flag and deleting it. So it's easy. Just click the actual flag in the graphics, hit the delete key, and that will eliminate a constraint. Can we do two concentric circles to create a tube? Yes. Yes. So you can create nested contours within your swept profile, like a circle inside of a circle, and sweep that as well. That would work just fine. Is 3D Sketch coming? Yes, absolutely. That is something that's on our list of priorities, absolutely. All right, so I have two parts, the two necessary pieces to my sweep, right? I have my profile, the circle. I have the path, which is the U-shaped sketch. And again, stressing, make sure to attach that profile to the path with either coincident or pierce constraints. But now I'm ready to sweep. So I hit the green check, and now I have my two pieces. Let's go to the sweep command in the toolbar. Real quickly, surface sweep, a question that was asked. All of the commands, extrude, revolve, sweep, and loft, all have a surface option at the top. So if you want to create a surface sweep as opposed to a solid sweep, just choose that and then choose your contours. All right, so I have this solid sweep. I want to choose my face or sketch region to sweep, right? In this case, this is my profile. I'll just select the circle. Then I choose my sweep path. Left click in the box, then select it. Now a tip, you can left click on the individual pieces in the graphics, but if you have dozens of lines and arcs, that's not going to be the solution that you're looking for, right? You don't want to left click each individual one. So again, you can select them individually, but you can also just select the entire sketch from the feature list. Especially important when your sweep consists of many, many things, and selecting them individually just doesn't make a lot of sense, right? So just keep in mind, clicking on the sketch in the feature list will automatically grab everything in that sketch and assume that's what you want to use as your path, right? Which in this example is what I want. So I hit the green check, and there is our simple sweep. Okay. So again, profile and path, the big tips to keep in mind, make sure that in general, you're going to probably need to insert a plane normal to the end of your path, and then attach that profile to the path either using coincident or pierce constraint. Can I delete constraints in iOS? Yes. You can show constraints and select them, tap them, and two-finger tap delete. There's a few different ways you could do that. But yes, there's also a sketch menu which will show you the constraints. So just keep in mind. Another tip that I have, we've done this a few times in the past, but we actually have a mobile essentials webinar on our YouTube channel. So if you're interested in mobile specific tips and tricks and things like that, definitely check out the essentials webinar, the mobile essentials. You can do a search on your YouTube channel and find that. Okay, so that's revolve and sweep. Now let's get into the loft command. Now the loft command is, of course, a lot more detailed. You can do a lot more things with it. You can create a lot more creative shapes, so to speak. But, of course, that means that it takes more time and more control. So a question that's popped up, is helical sweep possible? Yes, that's how you would create a thread, by the way. Sweep a helix along a part, and then thread, sweep a triangle along a helix to create a thread. So that's the next question as well. How would you add threads to a U-bolt? I would sketch a triangle, sweep it along a helix, and generate a thread. Now, I should say, in the FeatureScript library of features, there's actually a thread feature that allows you to click on a face, and it will generate a thread based on the pitch that you define, and so on. But in reality, it's generating a sweep in the background. So a sweep is what you would use to create a thread, a helical sweep in particular. Yeah. And by the way, I should mention we do have a dedicated helix command in the toolbar here, and that's what you would use. All right, so moving on to the loft command. Now, the loft command is detailed. There's a lot of information there, so I want to get through as much of it as possible. And I want to start really simple, and I think the most complex problem that you're going to have with the loft is how to get it straight, so to speak, how to get the transition looking the way you want. And to describe what I mean by this, if I just give you a simple example of a square to round, and it's not the round is not perfectly centered within the square, right? So when you loft shapes like this, one of the most complex things to determine is how the transition is going to look, right? And so if I just do a very basic loft between a square to a circle, you're going to see Onshape guess at the transition and how it should look, right? It's a circle and a square. They have, one has 4 vertices, one has nothing, and so it has to essentially guess at the transition between shapes. Now, there is a few things that you can do to control this, and it really just depends, what level of control do you want over the transition of the shape. So this is what you're going to get if you just keep it really simple. Rectangle, circle, loft between them, it's going to guess. And if you're okay with that, then you're good to go, right? You don't need to do anything further. But one of the first tips that I can give you with a loft command is it can be very helpful to have the same number of vertices on each profile. And what I mean by that is, a rectangle has 4 points, right? A circle has no points on the outside. And so Onshape doesn't know that this point or over here should line up with this. But what I can do is I can split this circle into 4 pieces. And then when we go to loft, it's able to recognize that the transition between those points should line up. And you can even define, hey, I want to line these vertices up. Now, there's a few techniques you can use for defining, how you want these profiles to look and how you want to split it. For time's sake, I'm not going to spend a lot of time going through, splitting this into a lot of detail and adding crazy dimensions. So forgive me. But what I generally do in something like this is I would construct, some kind of construction lines that give me some kind of gauge to the shape behind it, right? And I may even come in and constrain them, right? And maybe even add dimensions. It just depends on the time. Again, I'm just going to try and fly through things here. But constrain it to all 4 corners, maybe come in and add my dimensions. But once I'm satisfied with the locations, these lines give me useful references to split the circle. And that's ultimately the goal. By splitting the circle, I create 4 vertices on it, and those vertices can line up with those points on the rectangle when I go to do my loft, right? So I'm going to use the split command while in the sketch, and then just click the end points of those lines, and it will split exactly at those points, right? So point, and now I have 4 pieces to the circle. So the circle's just been split into 4 pieces. The neat thing, though, is it's split right at those points where I have the construction line ending, and it gives it a useful way to align the loft without a lot more effort, right? And that's really the thing to stress is this is kind of the first line of defense when we talk about creating a loft transition that you want, right? Controlling that transition. Now, first attempt is always going to give you a little bit more twist. Well, I shouldn't say always, but many times you're going to get twists that you may not necessarily want. This is one of the first things you can do to correct it. So I can hit the green check. And now, instead of having just one circle to loft between, it has essentially 4 arcs that it can line up with, right? So as I select the 2, I'm going to get a much more predictable transition, exactly where I split those points up along the circle, right? Why not split the circle via degrees on the circle? You absolutely could. It depends on your design intent. As I mentioned before, I didn't want to go through the effort of just defining the dimensions for degrees for every one of those lines for the sake of time. But again, in your example, I'm sure you can split it any way you'd want using any combination of degree dimensions that you want. All right, so I've split the circle, and as you can see, when I loft between a split circle, it lofts between the vertices that I define are created when I split it. So that's one of my first tips. In general, with the loft command, have the same number of vertices on each profile. It will help to align the transition between shapes, right? Now, one other thing I want to mention is you can manually match two vertices of a loft. So I can actually come in, and if it wasn't aligning the vertices that I wanted, I can just left click, 2 points, and it will force those to be aligned. So match vertices is great if if it's transitioning between the points, but then it's twisted relative to one, right? I can say, no, these 2 points should align, and that should shift everything else around. So again, match vertices is an easy way to align points if you're getting twist, and it's easy for you to just click 2 points and say align these. Now, what about if we want even more control over this? And this is when we start to get into more of the effort involved in getting the shape that you want. We get into guides and in conditions. So with a simple loft like this, there's not much to it. You just have the same number of profiles, but there may be a scenario with something like this where you have to, for instance, loft between two very different shapes, and the curvature between those shapes is really important, right? So an example like this is the squeegee, where I'm designing this handle and I want a nice smooth transition from the handle down to the actual finished profile, which is just this rectangle inside the shape here. And one tip that I want to point out is you can loft between faces and even non-planar faces. So you can click on non-planar faces and loft between them, and you can click on planar faces like this one. I don't have to create a sketch like I was showing you earlier. Now, one big benefit of this, if I do loft, let's select the face, and we'll choose sketch 16 from our list right here. So now I'm lofting between these two. Now, one big benefit of this, one thing that I want to mention is, let's say that I'm not satisfied with the sharp transition of the loft between the two contours, right? I don't care for this sharp bend or break in the contour. I want a gradual transition. There's a few ways that I can really manipulate the loft transition. I've already shown you how to split your profiles up, and I can easily do that to this and get a little bit straighter transition, but it still wouldn't help in that sudden sharp transition from my handle. So an answer to this will be what we refer to as end conditions in your loft. And the neat thing about end conditions is you can say, I want you to, for the first, match the curvature. And we'll actually go in and match the surrounding handle and make sure that you have true continuity between this face and this face before it transitions into the next profile. So one big tip, you can use end conditions, you can match curvature, you can match tangency, right? So you can get true continuity. You can also do normal to and tangent to profile and actually set a magnitude, right? I can extend that transition if I wanted to with that start at magnitude. Keep in mind, with an end condition, you have a start end condition and a end end condition. If your loft has many profiles, you really don't have a lot of control over each individual one. It's a start and end definition. So this is one thing to consider. It's very easy to do. Just click the drop down, set your magnitude. The loft, of course, live updates, so you're going to see it immediately. And the big thing is, of course, are you satisfied with the result? So if you've gone through this much and match curvature or match tangent or normal profile, or none of these end conditions give you the exact shape that you're looking for, then you'll need to create guides. And guides are definitely something that it takes more effort. It certainly takes more time, but it gives you very exact control over the shape, right? So to give you an example here, I actually have a few sketches already created here, right? Let's go ahead and hide the loft. We'll roll back before it. And you can see it's essentially just 4 splines. And these splines are the exact transition that I want between the two profiles. Very much like the sweep I was showing you earlier, there's an important step. Make sure that your guide is attached to your loft profile in some way, either using Pierce or coincident, right? So essentially the same rule as the sweep command. When you're attaching your profile to your path, you must attach your guide to your profile in some way. And if your loft has many profiles, the same rule applies for points along your guide. Right? So if you create a spline with several points, make sure that each spline point is attached to your loft profile in some way, either using Pierce or coincident. So again, big tip when you're creating guides, guides are definitely the most work, but they give you the most control of the shape. Make sure they're attached to each loft profile. Okay? In this example, you can see I have a Pierce constraint attaching the end of the spline here, and I have a coincident constraint attaching the end of the spline to the sketch profile that we're lofting to. Now, what this gives me is very specific control, right? Now, my loft is following those exact contours. What this means, though, is it's really easy for me to manipulate the loft geometry just by changing those guides around, right? So let me give you an example of this. Here's the loft, and by the way, I mentioned you'll see right here guides, and it's just a matter of clicking on each guide in your loft. What this allows me to do, though, is change things quickly and see them update. And a tip that I have is, let's say this is one of the guides, by the way, this is one of the guide sketches, and it's just a simple spline that joins the two profiles. But it's easy for me to make a change here and see the loft update. Now, a big tip when you're doing this is in any sketch or feature that's been generated and used in the part, you're going to see a final button in the dialog. And the neat thing is if you click this, it's going to give you the final end result. It's going to rebuild the model live. And really useful if you're playing with a loft and I want to grab and drag and see what it looks like, it's going to update instantly. So you can edit the sketch, click final, grab the spline, play with it, manipulate it as you'd like, and then instantly see that loft update without having to go back and forth between the feature and the sketch. So a tip is, again, final button, and when you're using guides, this is a really useful tool, right? So again, guides, the key thing with them, they are going to take the most time. These are individually constructed splines. So, of course, this is what many would consider the last resort, but oftentimes if you want very specific control over the loft transition, it's the necessary thing to do, right? So in this case, you can see I actually have 4 separate sketches for each one of the guides, and I can control them independently. So that is in detail, as much detail as I can get into the loft command. A few questions that I have not gotten into. Can loft lines be repositioned easily? You can edit the sketch like I've done here and use final to manipulate and then see the effect immediately. That's what I'd recommend if you find yourself having to reposition or move loft geometry a lot, is use that final button, and it just saves you from having to go back and forth and editing sketches. Can you update cut point after loft is done? Forgive me. If you're referring to the split from earlier, can you update the split point? You can move it. It's going to be constrained relative to the construction line. But just keep in mind, you can. It's no different than any other sketch. So, what if I want to loft using as well a path to follow? You're probably looking for a guide, which is what I would use here. So remember, you can use a guide to determine the transition. A good example of that, by the way, would be the actual loft for the handle of this. So this is just a simple loft between 2 circles, but the guide determines that grip profile that you see. Right. So a guide will just give you the transition or control the transition between the 2 shapes. Can I use 3D Connection Space Mouse on Onshape? Yes. Make sure to download the latest driver for your 3D Space Mouse from 3D Connection. And if you're using Mac or Windows, it works great in Onshape. Just make sure you have the latest driver. Can you turn a loft into a flat pattern to get can you turn a loft into a sheet metal? Yes. I would say that this is a little bit more complicated. There's no dedicated lofted command for sheet metal. I would say that that's something we're working on. Can you give some guidance on getting successful with match, curvature, and sweep? Almost all of my parent reasonable attempts fail. Well, the thing with match curvature is it has to have a long, it has to be able to blend with the surface over a long period. And the easiest thing that I could say is, if there's some abrupt change in geometry or face or something like that that would stop it from being able to match curvature, that's probably not the answer you're looking for, I'm sure. But in this example, I have a long amount of time before the transition that allows it to match the curvature successfully. So the longer transition between shapes, the more likely that is. If you have an abrupt transition or surrounding sharp faces that it can't match against, then that is when you tend to run into problems. Very general advice, I realize. So can you turn... Oh, I already covered that. Forgive me. Can we make splines symmetric in this case? No, it's important to point out each guide has independent control over each corner, so there's no way to define symmetry using one guide in this example. So in this example, you would need 4 independent. Can I view this later? Yes, we will upload these webinars to YouTube. All of our webinars, by the way, you can find by searching on YouTube. We have a playlist of past webinars. This is off topic. How did you make the bumps in the handle? That's just a guide in the loft, right? So you can see a guide sketch, and this is a loft between 2 circles using a guide that has those bumps. Is match curvature match for tangential matches more than a fillet match? Fillet matches keep failing. A match curvature is different than match tangency in the sense that you have C1 and C2 types of continuity. Generally, match tangency is going to give you a little bit more loose rules in terms of how it matches with the geometry. Is final really just a temporary preview? You could call it that. It is rebuilding the model live. So yeah, I think that's a safe way to. It's just rebuilding everything in the geometry live for you. Can I use solid edges as guides? Yes, but they would need to be tangent. You would need to have one continuous edge to define that as a guide. So in rare situations, yes. Most often, I would say no. You're probably going to need to construct something. Can I make the spline tangent to the handle? Yes, you could. You can easily attach constraints to the spline handles. Can you show how the grip was done? Again, it's just a simple loft between 2 circles, right? So face of sketch 1, which is just a circle, and face of sketch 12, which is just a circle. The key difference, the grip, so to speak, comes in with the spline that's, in this case, a guide in the loft, right? So very similar to this transition between them in that you have a transition between circle to rectangle, but you want to control it with the guide. In this case, the guide is what creates that. Okay. Can you please show how to create a plane for spline guides? Yes, it's just a 3-point plane. So if I go back, let's see, I believe this is one of them here. Yep. So plane 1, if I edit plane 1, it's just a plane between 3 points. 2 points on the rectangle, 1 point on the circle. Okay. All right, so moving on, that is the loft command. Now, one last thing I want to mention about the loft command before we move on, and it's already been brought up briefly, but I wanted to mention it again, and that is you can, any one of these commands, revolve, sweep, loft, extrude, all have a surfacing equivalent. So if you're doing any kind of surface modeling, let's say that I'm designing like a mouse, for instance, and I want to loft my shape, just realize I can click loft, choose surface, and then just choose any open contour that I want to loft between, right? So now I'm lofting a surface between this contour and this contour of my mouse, and I can add a guide and define this arc as a guide, right? So it's really easy to do that kind of surface modeling techniques, even lofting between boundary definitions just by saying, arc, edge, and then using a guide. Okay. So just keep in mind, again, and this goes for loft, revolve, sweep, all of them have the surface equivalent at the top of the dialog. Question: will synchronous direct modeling change the guide curve or only the surface of the loft? When you edit a sketch of the guide, you're editing the geometry in one. One drives the other. So you can't change the surface of the loft without changing. You can't change the guide, not change the surface of the loft. I guess that's the way to put it. Can we turn that surface mouse into a model? Yes, you can thicken. There is a command for thicken. Can you demo evaluating curvature? If you're referred to curvature visualization, the option in the drop-down menu, you'll find it here. Forgive me, I'm not sure what you mean by evaluating. If you're just referring to showing the curvature, you can find it in the drop-down, curvature visualization. All right, so moving on, let's get into, I'm almost out of time here and we've got a lot to cover. So I want to get into the hole feature real quickly. Now, the key thing with the hole feature is you want a standard hole, all right, of some size, counterbore half 13 inch or, counterbore 10 millimeter, right? I don't want to look up the values. I don't want to sketch the revolve profile. I just want a simple way to create a hole. And that's where you would use hole feature. Now, the key thing with hole feature is you need to have a point to reference for your hole. So the first step in creating any holes is sketching points. And you can see I already have a few here. So I have points here, here, over here. I actually have a few different sketches with points on them. And so I'll click the hole feature in the toolbar, right? I'll choose my hole type, simple, counterbore, countersink. And this says, let's say a counterbore. Let's choose a size, half inch, right? 13 threads per inch. It's going to then pull up all the values for the hole. And then it's just a matter of clicking on a point to place the hole, right? That is an awfully big hole for that size. Let's choose something a little bit smaller. So 3/8. There we go. All right, so 3/8 counterbore, just a matter of clicking a point. All right, let's choose something even smaller here. All right, so now we have our first one. Now, I want to point something out in particular, and you'll notice these points, two of these points kind of float out in space. The one thing I would stress about the hole feature is you don't really have to be super critical about where the point is with respect to the geometry. So if I wanted a counterbore, that goes through the side of this, rounded shape, I could put a point well above that shape or well above the geometry, reference it for my feature. What Onshape does is it will project down to recognize where the geometry is and start the hole from that point. So again, I can have a situation where my point is well above where the hole would actually start, and Onshape will look and recognize, hey, the geometry is down here. I'm going to start my hole down here and still give myself a full counterbore into the part, right? So same thing, for several holes. You can click on as many points as you'd like. You can even click on points in multiple directions. So you can see if I click a point here, now I'm creating a counterbore going in a separate direction. It uses the normal direction of the point to determine the direction of the hole. So you can essentially sketch all your points for all your holes in one shot and then go in and create the hole features for each size. So questions, one of the common questions, I can already see it here. Threads, how do you show threads? Is hole tapping a new feature? There are no display of the threads. It will give you the pitch circle diameter, but there's no cutting of the actual thread. There is script features that will accomplish that, but the hole feature does not. So just keep in mind, no display of the threads or the cosmetic threads. Now, when you use the hole feature, you do get the benefit of automated hole callouts in the drawing, right? So you can automatically insert a hole callout and link it to the hole information that you specify here, and if you change it, the drawing will update. So just keep that in mind. That's one of the big benefits of using the hole feature, is that hole callout at the drawing level. questions. This is a question from, how do you sketch the transition between the blue and yellow orange on the mouse? It's the join of two extrude features. So you create two extrude features, extrude them in both directions, and where they join creates an edge. Could you show how to create a loft between a circle and a rectangle by matching the vertices? It's very similar to what I showed earlier, so forgive me. This will be recorded, so you can go back and watch that first example, by the way, which is a rectangle to circle transition. Whole features and assemblies. Remember, we can create in context at the assembly level, so yes. How does it know which direction to make the hole? Remember that it uses the normal direction of the sketch plane that the point is on. So when you click a point, that point has a sketch plane, which therefore has a normal direction, and that's what it's going to use. Okay. Are threads shown literal for illustration? They're not shown at all, no. You will get a whole call out, which is what most users are looking for in the drawing level. Okay. Holes, points have directions. How can I have points have directions? A point is sketched on a plane, and a plane has a direction. Holes inside show threads. No threads, no. Pattern holes, absolutely. Yes, you can linear pattern, circular pattern, curve pattern. It's a feature no different than anything else. Can you show how to render the threads? No, we won't get into that. We actually have a tip, by the way, creating a thread. If you just do a search, create a thread in 60 seconds, there's a separate video of that. Is it problematic for Onshape performance to show actual threads? I wouldn't say that it's problematic. It makes it, in many situations, I would say, unnecessarily detailed. Threads, actually cutting the threads doesn't help for the CAM process, for example. I think the benefit and the reason people like it is it looks very nice and it shows up very nice in the drawing. 9 out of 10 customers we work with just want to see the whole call in the drawing, saying this is the thread dimensions, and that's something you get, here, but it's not displaying the threads. Any display of threads is going to make it more detailed. I wouldn't say that necessarily is complicated or difficult for us, but it's unnecessary in many situations. All right, so we are very close to being out of time, so I want to move on. That's a simple explanation of the whole feature. The next thing that I wanted to show was an example of the shell. I'm going to come back to the squeegee example from earlier. And a shell is a very simple command to show. Essentially what it gives you is a part with uniform hollow thickness, right? So if we look at our handle, this may be, some kind of an injection molded part where, it's split in half and it needs to have a, uniform wall thickness. It's not a solid part, right? So if we go to let's say we do a section view here on the front plane, you can see right now the handle is solid. Right, both lofts create a solid part, and that's clearly not what we want in this. Maybe we need to shell it and then split it and do all the things we need to actually make this. So the key thing with the shell command, very simple. Click the shell command in the toolbar, click on any faces that you want to remove, and then set your thickness. Right? Now, you do have the option, and I should point this out, for what we call hollow. And like the name implies, you don't have to remove a face, you just simply make a part hollow. It doesn't get rid of any faces. But in my example, I actually want to get rid of the end face of this part, right? So as I click the end face, you can see it generates a shell, and now I have a hollow handle to the part. Now I can move on to my split or whatever operations I need to do after this. But essentially, it goes through the part, creates a shell of the part at the thickness you specify. Right? You can shell outwards if you choose to by flipping the direction, opposite direction. But that's really it. I hit the green check, and now if I do that same section view, of course, now we have a hollow part. Okay. So a real simple example of the shell command. Keep in mind you don't have to remove a face. You can just say, make this part hollow, and there's a checkbox for that. But in my example, I wanted to make the end of this squeegee open, so that's one of the faces to remove. All right, so that's a simple explanation of the shell command. Let's move on to the next one on my list, which is the derived feature. So let's say that you've imported geometry and you need to work around that geometry. So I have 2 parasolid files that I've been sent, a bottom casing and a top casing. and I need to bring these two files together in the same Part Studio and model a part around those parts. So this is a commonly asked question: what techniques would I use to accomplish this? And one of the first commands you'll need is the derived feature. So I can click derived after I've imported my files. I click derive, and this derived command will allow me to insert a part or sketch or plane, whatever it may be, into the Part Studio. All right, so I have two different parasolids. They're in two different tabs. I need to bring them together. I use the derived feature to accomplish this. Right, so I click derived. I click on the part that I want to insert, and now I've inserted that part into this Part Studio. Right. And I can do this as much as I'd like, and you can insert as many parts into the single Part Studio that you'd like, but it's very easy for me to insert and place them. Now, you can also accomplish very similar things using in-context design in assemblies. So just keep in mind that they have some overlap in the way they work, and it's really in some cases a matter of choice. But the derived feature is easy to drop in your parts and then start modeling around those parts. Right? So now I can start sketching my geometry. Let's say that I wanted to make something like a simple gasket that attaches to these. Right? It's easy for me to constrain relative to the geometry. Even convert edges. Right? I can grab edges of the parasolid, grab them, convert them, and take this and extrude it and create that that simple flange. Okay. So now I've built a part relative to two imported parts that I brought in using the derived feature. Now, one thing I want to stress when you do this is when you make a change and everything's in the same Part Studio. So let's do a simple move face. Let's do an offset of, say, 0.75. Right? So I'm making this outlet diameter on these casings smaller. The question becomes, what happens to where it was derived? So I've made both outlets smaller. When I go back to my Part Studio, they will automatically update. Now, because everything's in the same document, it updates live. Now, if it's in different documents, you would need to create a version, and then you'll see an option to update. Okay. All right, so that's the derived feature. Very useful in scenarios like this when I need to import and work around other geometry. As I mentioned before, one other option to consider is in-context assembly design. It also gives you very similar results. All right, so let's move on. Now, the last things that I'm going to have time to get into are the various patterns. And I wanted to get into linear and circular patterns, and if we have a moment, curve patterns, forgive me. So we'll start with a simple linear pattern of a feature. It's important to point out, we'll click linear pattern here in the toolbar. You can pattern three different things. You can pattern a part, a feature, or a face. In my case, I want to pattern this boss, right? In this case, extrude to and the fillets that join it. So I'm going to choose feature pattern and click on the extrude and the fillet for that feature. Then I define a direction. I'll just click on an edge of the part that defines the direction I want to pattern. And then set, in this case, reverse direction, set my instance. Let's set them to 10. Right? Green check OK. And now I have 10 instances of that extrude. Now, one thing I always like to point out with this is notice that it's patterning the feature. The feature uses an up to next in condition, which means as I pattern the feature, that up to next in condition is maintained even in all these pattern instances. It's not doing a dumb pattern, so to speak, of just the geometry. It recognizes that as this is changing, up to next would extend these variations further than these. So it's a very smart command. Just keep in mind the feature patterns. You can pattern as many features as you'd like, and it's actually patterning the function, the actual operation. So, all right, so that's a simple example of linear pattern. I know we are out of time, so bear with me. Last example that I have for you is circular pattern. Like the name implies, it patterns around a circular shape, right? So we'll choose a feature pattern, just like in the linear pattern options. We'll choose extrude to and the fillet that goes with it, and then define an axis of pattern. I use any cylindrical edge or circular edge or cylindrical face. In this case, just the edge of the part here. And there we have our circular pattern. Okay. So that is what I have time to cover. Forgive me. I am going to stick around and answer all questions. So keep in mind, if you have any questions that I haven't answered, just stick around. I will make sure to get to them. I do have one question real quickly going forward. Well, we'll do that later, so forgive me. All right, so let's move on. I want to say thank you, everyone. Jumping back real quickly here. Going forward, if you're just getting started with Onshape, I really encourage you to try Onshape in your professional work and give us your feedback. There's a feedback tool built into Onshape. We tried to make that easy for you. Also, invite others and share. We really encourage you to share with others and use the real-time collaboration that you get in Onshape. The last thing is, if you're interested in meeting local users or establishing a user group, we'd love to hear from you. We'd love to help you set things up. So, forgive me, I know I haven't had time to get through everything. If you are interested in variables in particular, we have done a separate webinar on that, so definitely check that out. We've also have a video on it if you do a quick search. We will be posting this online, and I want to say thank you, everyone, and have a good day.